Hey team, Ben Lawless here. I'm going to do a live demo of how to do a Guttman chart based on a rubric and some dummy data.
So here is the rubric. You'll note that it's got all of the criteria numbered. So you need to use this exact numbering system, yeah? 1 dot, 1.0 showing not shown. Well, they should say not shown. Yep. Every single one of these criteria's got a number. Right, here's my data right here. Had a class with, here's the name of the skills. Now you'll notice, so we've got to do a bit of data manipulation here. We might make mistakes. We don't want to stuff up the original data. So I'm going to copy that tab. Move or copy. Boom. I'm going to work on this one. You'll notice that this data has 2s and 3s. So the 3 means that the student got the third criteria for that. We need to turn this into dichotomous data to make a Guttman chart. So we need to make it into data that's only got 1s and 0s. So I'm going to rename that student data dichotomous. Now I know that I work quickly, so if you need to go back and rewatch stuff. I'm going to insert a little row here that I'm going to call criteria because I want to know the name of each of the criteria. So I need to split these numbers up into individual criteria. We know that there are 4 criteria, including the not shown for each. So I'm going to have 1, 2, yeah, got enough spaces there. So we're going to go like this. Take the rubric, that's not shown. Yep, maybe we'll just do this first one first and then we'll be able to speed up. So a 2 means that the student was able to do list questions and was able to ask specific questions, but they weren't able to do number 3. Yep. So, yeah, actually, let's leave that one out. So a 3 means the student got that one, and that one. Another 3. You're just going here, through here, and translating all of these. Some of you might have access to something that does this automatically, or you can use Visual Basic to get it to automate this task. There we go. So now I delete that, and that shows that's now in dichotomous data. I need to put 0s in there for all the ones that weren't done. Should have done that at the time. Right, that's the first skill done. Next one, let's insert. Let's get those, paste in the names of those criteria. That's the second one done. We can now delete that. Okay, awesome. We have done the setup. So now, just to like putting little boxes around everything. So now let's just think about what we're looking at here. A 1 means the student has demonstrated that they can do that, and a 0 means that they haven't demonstrated that they can do that. This only works if the rubric is well written and written according to developmental principles. The higher criteria assume that the student is able to do these other things as well, either because they were demonstrated in the task or because that skill requires them to have done one of the earlier ones, whatever. Now what we're going to do is we're going to generate some totals. So you can just do auto sum if you want, boom. That just adds up how many criteria that student had in total. We can double click on, see a little green square, you double click on that, auto fills the formula right down at the bottom. We also want to count, so that's this count of how many criteria each student was able to demonstrate out of, what do we got there? It's out of 12. And this one, and now we do a total down here, and this is going to calculate how often each criteria was awarded. Now, the more a criteria was awarded, the simpler that criteria is, basically. Do another little auto sum here. Boom. So we've got 24 students. No, we've got 28 students, and 25 of them were able to list questions. So 3 students didn't even get to that point. So there you go. Copy that across. Right. So we've got our totals. Yay. Now we need to sort vertically and sort horizontally. Boom. Right. So I'm going to grab my data like that. See, I'm not selecting. Actually, no, I'm selecting it all. And I want to sort this top to bottom that way, pardon me. So I'm going to go up to my sort, custom sort. I want to sort it. Here we are sorting top to bottom. Yep, we want to sort by, what do we want to sort by total. And we want the cell values to be the largest to the smallest. Boom. There you go. So that means that's the highest ability student at the top and the lowest ability student at the bottom. Now we're going to sort left to right to sort how easy each criteria is. So we're going to sort now. This is hidden behind one extra menu. So you go custom sort, but you got to go into here, options, sort left to right. If you don't do that, you won't be able to get what I'm looking at. Now we want to sort it by the row. Oh, I can't remember the row. We have to go down and have a look because it hasn't got a header. It's row 30. It's got the numbers we want to sort by. Sort, custom sort, options, left to right, row 30, cell values largest to smallest, boom. And now that's got the easiest criteria on the left and the hardest criteria on the right. Good thing to make this look a bit easier to analyze is to do a bit of conditional formatting on it. So you're going to go to conditional formatting. A few different ways you can do this. I just go new rule, format all cells based on only cells that contain cell value equal to 1. So if there's a 1 in it, I want you to shade it a nice little green there. Ta-da! Okay, now let me tell you a few things about this. You'll notice that all the dot 1s within each skill come before the dot 2s, right? So there's a 1.1 and then the 1.2 and then the 1.3. 4.1, 4.2, 4.3, yeah. Remember, on a rubric, we are saying that difficulty goes up vertically within each skill, but we're not making any claims about whether or not all the 0.1s are equal difficulty, all the 0.2s are equal difficulty, all the 0.3s are equal difficulty. That's what we can use Guttman analysis to find out, right? This is fairly straightforward data, and it does have all the 1s, all the 2s, all the 3s, but it might not necessarily. Anyway, so you hope to see a shape kind of like this, right? You'll notice that it goes on a diagonal. Let me just get a little arrow up there to show you. See? The perfect Guttman that has no noise would look something like that, where like the students can do. The point here is that we're mapping student ability with difficulty of the criteria. And so what you would expect if the criteria are well written and that the task is reliable and valid is that higher ability students are able to do more difficult stuff. So they're able to do the more difficult criteria easily. You usually find that there's some noise in your data, right? So the way to do it, there's two main forms of analysis to do it before you even bother going down the route of looking at zones of proximal development. According to Rash modelling and stuff, what you see when a student shows a skill is that it goes 1, 1, 1, 1, 1. They can do it. Then you see this breakdown pattern, 1, 0, 1, 0, something roughly like that. And then 0, 0, 0, 0, 0, 0, right? So the ones is they can do it. Ones and zeros, that's their zone of proximal development when they can do that skill roughly half the time. And then the zeros is beyond their zone of proximal development. They haven't got there yet. So what we do is we look through to see if those patterns are being filled. If they're not being filled, then that makes us got to make us ask a few questions. So firstly, we do the vertical analysis. Does it go? Are we seeing big divergences in our patterns? So you might notice here you've got your 2 zeros, but of course these totals are exactly the same. It makes no difference to our analysis if we move those two around, right? Then it looks slightly better. If the totals are the same, you can flip them around if you want. So you've got your 3 12s here. So if I cut that and stick it in there, it looks slightly nicer. Makes no difference because they're all 12s. Right. So that looks fine. 2.1 looks sketchy. You'll notice that we've got the lowest ability student is able to do that. So when you have irregular patterns vertically, I would go back to the rubric criteria and think, is that a well-written criteria? Generally, if the vertical patterns are all over the show, that means it's something in your rubric criteria that's not great. So let's have a look at this one. Uses observations to suggest features of civilization that made it. Have a look at how wordy that criteria is compared to the other ones, right? So Guttman analysis can do a whole heap of things, but one of the big ones is that you can use it to actually assess the quality of the rubric that you've written. If you're not seeing good patterns in your Guttman, then there's probably something weird about your rubric. But so this is just for our own information. Next time, we might want to have a look a bit more closely at the criteria if they don't have good patterns. But this one here, again, you got these 3 students here that are doing it, and yet these supposedly more able students couldn't do it. Of course, you notice this is a slightly unrealistic scenario because there's so many students that are bunched up in the middle. Anyway, another one, ask open-ended specific questions. You'll notice that actually both of our question-asking ones are slightly sketchy. And my hunch is because of the ambiguity around the word specific. I don't know that teachers and students all agree on what the word specific means. And if they don't, then they will mark it inconsistently. It's all good though. How about this one here? These ones are a bit longer. Oh, it's flipped out. Here we go. Oh, that's a fun little thing it does. That one there, again, it's sort of an okay pattern. You would kind of expect more ones up here. Gives convincing explanation for why artifact was placed on timeline. The word convincing, I would probably, if I was rewriting that criteria, instead of calling it gives convincing explanation, let's just turn the text wrap off, I would say explains why artifact placed on time 1. It's got the same content, the same meaning as the one above it, just look how much shorter it is. Makes it easier for students to understand and easier for teachers to mark. Anyway, finally, uses independent research to look to back up evidence from artifact. You've got these 2 students down here who are doing it, so that's questionable. Maybe there's something about the word independent research. Maybe it's hard for the teacher to know whether their research was independent or not. Anyway, so the vertical analysis will tell you the quality of the criteria. If you do a Guttman chart on a multiple choice question, on a multiple choice test, it can be really useful for finding out which of your questions are dodgy. Now, there's a lot of noise in a multiple choice test, Guttman, because there's only 4 options and students can guess 25% of the time correctly. But if you're finding that there's just heaps of guessing, then it might make you have a look at the quality of the question that you've asked in the first place. Okay, so we'll pretend we've done our vertical analysis. We're pretty happy with all the criteria. We might want to rewrite some more for next year. Then you go along and have a look at the exact same patterns going left to right. This is looking at the students. Now, you will know your students, so if you see anything weird in the patterns, then you possibly know the reason. So like this guy, James, he couldn't do those 3, which were easier, and yet he is able to do that one, which is a bit more tricky. So we might think, well, why can he do that one that's harder than these 3? Don't know. Maybe you know something about the student that explains why that is. Another even better example of one with noise is this one here, Charlotte, right? Charlotte breakdown pattern. Remember, 1010 is roughly the ZPD. So her zone is probably right about here, and yet she was able to do that one. So we might know something specific about that student as to why they were able to demonstrate that skill, even though they couldn't do these ones here, which should technically be easier. So if you don't have that perfect line, which you never will, the perfect diagonal going through, then have a look and see if there's any noise, and then that might help you to improve the assessment next time you run it. It might also tell you stuff about students. You know, it might be that the student was away when you taught that part of the unit or whatever. Now we're going to put them into zone of proximal development groups. So in a ZPD group, so if you remember Vygotsky, ZAD is your zone of actual development. That's what the students can do independently. Students should still be asked to practice stuff that's in their zone of actual development so that they automate it and can do it flawlessly without putting in a lot of cognitive load. Your zone of proximal development is a ZPD. That's where zone of proximal development, that is where the student's point of readiness is. This is what some people call the Goldilocks zone, yeah? So where it's not too hard, not too easy. And teaching interventions at that point are going to be more impactful. Whether that zone of proximal development is what the student can do with the help of the more knowledgeable other, as Vygotsky says. Now, whether that's another student in the class, whether that's the teacher, or whether the teacher has prepared a video or some written material, the more knowledgeable other does not always need to be the teacher. That's an inefficiency bottleneck, the idea that it always has to be the classroom teacher. Anyway, we're going to do some outside border mapping. So what you want to do is you want to find groups of students where their pattern of what they can do runs out roughly. First thing I would like to point out here is that with Alexander, we possibly don't know his actual zone of proximal development because he got 10 out of a possible 12 criteria. Although we've got a problem there. It should be out of 12. Why is he only getting a 10? There we go. I stuffed it up. I must have done something wrong. So this might change my ordering. No, it's fine because everyone had done that. Okay. So he got 11 out of 12. So he might have been able to demonstrate even higher criteria. So that's why it's a really good idea when you write a developmental rubric to make sure that your top criteria is a stretch even for your best students. You don't want more than about 10% of kids getting those top criteria. And if heaps of students are getting that top criteria, then it's obviously not hard enough. So next time, write an even harder one. So for Alex, possibly we can't work out a ZPD, but for the purposes of this, we're just going to put them in the top one. So all my students, I'm going to say those people there, I reckon that's one. Now, putting students in zones of proximal development is an art form more than a science, to be perfectly honest. I'm going to do thick outside borders, but I want to colour it. I just find that's a bit easier. Let's give them the blue one. There we go. Oh, hello. I completely stuffed that up. Let's try that again. I think it makes more sense to pick the line colour first. Yes. Line colour, boom. Now I'm going to put that There we go. And got my little box. So that's zone of proximal development 1. The students in that group need to work on those 3 skills. Now, yes, we've got a problem down here because these are outliers, but you're always going to get a bit of noise, especially when you're only assessing one class. Next, zone of proximal development. Now, you want to make sure that there's 1s and 0s for each student, ideally. Now, it didn't work out for old Jack. Jack didn't have a 1 in there, but it's as close as we can get. Okay, our next zone of proximal development, probably all the way down to there. In a typical class of 25 to 30 students, you're generally going to find 3 or 4 zones of proximal development, I would say. I reckon that's another one there. So let's go pick a different colour. Let's go red. And then we're going to put a box around it. Oh, yep, did it. Here we go. And then my last zone of proximal development, I'm just going to have all these people down here. So let's say purple. Here we go. So I've got 3 zones of proximal development. I've got these students here. So I could say, ZPD 1 equals purple. ZPD 2 equals red. ZPD 3 equals blue. So the idea is that now we've got these 5 skills which are roughly similar difficulty, and they are the 5 skills that we'd want to teach students in this zone of proximal development. So you design a lesson that taught them that stuff. These students, their zone of proximal development are these 4. So I want to design an activity to teach them, and for those ones, it's those ones. I'm going to even color code the criteria. Ugh, that's slightly dark. Let's make that a lighter purple. Here we go. Red. Very angry looking red there. So there's some very interesting things that are able to be done with a Guttman chart. So the first thing is that you can use it to determine the quality of the assessment task. Anytime you do an assessment, it gives you information on 3 things: the ability of the learner, the effectiveness of the teaching, and the quality of the assessment itself. We know that this assessment is pretty good for putting them in zones of proximal development, although possibly not for Alexander. We've got a few criteria that we could probably improve for next time. It puts students in ability-based groups. Now, it's not true that fixed ability-based groups all the time is a good teaching strategy, but in terms of sequencing the material from easiest to hardest, a Guttman chart's really good. Yep. It just so happened in this bit of data that all the 1s and all the 2s and all the 3s lined up perfectly, but often when you do it, you find that, that skill there is only as hard as that, or something like that, when you do a more complex one. So we've got our groups. We've got suggestions for teaching those groups. What you really want to do, ideally, is you want to try and figure out what's the big idea that hides behind all of those 5. You'll notice here that it's about listing and using. Here, even on if I was talking from a solo taxonomy, that's they know, knows one thing. So that's kind of knows one thing. That's knows multiple things, and then this is able to do stuff, do something more interesting with it. So that is Guttman chart analysis.
So here is a screenshot of another Guttman chart. It's been quite clever and written the skills vertically, so you can sort of squeeze up the 1s and 0s. You can just readjust your column widths if you want to do that. So just bearing in mind, what is the purpose of a Guttman chart? You can use it to measure the relative difficulty of rubric criteria. You can use it to assess the assessment itself. You're matching the ability of the student with the difficulty of the criteria. You can use it, therefore, to place students in different groups based on their ability, the zone of proximal development, so that if you want to, you can use that to target teaching. Patrick Griffin, my old boss, really good at doing Guttman analysis. I highly recommend that you check out that video linked right there. Keep it real.